Okay, so I'm going to explain how bit clear works. Okay, first look at this. Look at this assembly language. So first, once you build the target, okay, make sure that the error is 0 and 0 for the warning as well, and then go to debug, and you can check line by line using the step. So let's start from the first line. So load R0 equivalent to pin cell 3. So what will happen is when I click the step, you can see that the address of pin cell 3 will go to the register R0. So pin cell 3 here, if you bring the cursor to pin cell 3, you can get the value in that address is 0, but the address number is 4002C00C. Okay, for the next instruction is what will happen is the value in R0, which is the address above, will be loaded into R1. So since there is nothing, the register, the value in address R0 is empty, so you can see there is nothing in R0, which is equivalent to 00000. Right, the next instruction is going to put the hexadecimal value of 1111 into R1. I'm going to put this value into R2, so you can see what will happen after this is R1 will become 1 1 1 1, and then for R2, if I press step, R2 will be this value. So what will happen after bit clear? So we'll see. When I press step, you can see that the value of R1 now become 0 1 1 0. This is because R2, the value in R2 will clear the value in R1, and that value will be stored into R1. So what happened is, actually, if you look at this one, so if you look at this whiteboard, R1 has a value of 1 1 1 1, and R2 has a value of 1 0 0 1. So since you want to bit clear R1 using R2, the value in R2, which hold a value of 1, will clear this one and this one, and these two, since they are 0, nothing will happen. So you can just bring 1 here, and this one, since this bit is 1, it's going to clear the value of 1 here and become 0, and same thing happened to this one. So that one, the new value of R1 will become 0 1 1 0. So this is why the value in register 1 is 0 1 1 0.